So this video is about when we have repeated roots in constant coefficient equations, and I'm actually going to start out by showing an example where this happens, and then we'll write out like how we knew to solve it. So we're going to consider the differential equation y double prime minus 10y prime plus 25y equal to 0. And we want to find the general solution. So we're going to assume that y is e to mx, then y prime is m e to mx, and y double prime is m squared e to mx. I'm going to start going through that step kind of quick because it's how we start it every time. Then the ODE is going to be 0 is equal to y double prime minus 10y prime plus 25y. That's going to give us that it should be equal to m squared e to mx minus 10m e to mx plus 25 e to mx. Yes, okay. And then I want to try and factor out that e to mx. So I've got m squared minus 10m plus 25 all times e to mx. That means I actually have to solve the equation 0 is equal to that part in square brackets I drew, m squared minus 10m plus 25. And if I want to factor this, it's going to be m minus 5 times m minus 5, because minus 5 times minus 5 is plus 25, and minus 5 plus minus 5 is minus 10. So I found m1 equals m2 equals 5. We don't have two roots, but I need two roots if I wanted to write y equals c1 e to m1x plus c2 e to m2x. I would get like c1 e to 5x plus c2 e to 5x. And they can't be the same thing because then when I go to try and solve for c1, c2, they're not different coefficients. They would sort of combine into one when I do an initial value problem. So that's no good. And I'm going to tell you right now, oops, too many equal signs. The solution is c1 e to 5x plus c2 x e to 5x, which makes that bad symbol confusing. I'll just write note. That's what the solution is going to be. We just multiply by x when we find the repeated root. And I'm going to go ahead and write that out in words so you kind of have it as a guideline in your notes somewhere. So first of these little like asterisks where in the steps we were missing a small detail is repeated roots. So if you have some root that I'll denote by m sub I, if it's repeated, and for higher order problems, it could be repeated many times. So this is second order, there are only two roots, so you could only repeat it once. But let's say you could repeat it up to p times. Then you're going to use the fundamental solutions for that particular root. Start with that e to m sub I x, same as you normally would. And then once it's been repeated, multiply by x. And then keep multiplying by x until you've built as many solutions as times it's repeated. So in this case, you would keep going until you multiply by x to the power p minus 1, since sort of we start by counting from 0 there. I'm going to just scooch that whole thing over because I didn't give myself enough room for m sub I x to be legible. There we go. So if you counted that list up, you would have p solutions. And that's all you have to do for repeated roots. In the next video, oh wait, no, I have another example for you. We're going to do an example. Okay, so we're going to consider one of those higher order examples. It's actually not going to give us more repeats though. I'll spoil it. So we've got y triple prime plus 3y double prime minus 4y equals 0. And we're gonna assume y is e to mx, or y prime is m e to mx, or y double prime is m squared e to mx, or y triple prime is m cubed e to mx. I know you all might be thinking it's kind of repetitive that I always write it down, and it is. But it's important to write it down to show what we're doing. So I want you to be in the habit of writing this out and showing me how you get your answer. If you start from the differential equation and just write your roots down for me, or even just write down the auxiliary equation, we're missing a lot of important steps in the middle. So I plug into my ODE, and I'm gonna have y triple prime, which was m cubed e to mx, plus 3, the second derivative, y double prime, that's m squared e to mx, minus 4 times y, which was just e to mx. And when I factor out that e to mx, I get m cubed plus 3m squared minus 4 e to mx. And so I want to go ahead and solve 0 equal to m cubed plus 3m squared minus 4. This is a cubic equation. There's a very gross, messy formula for the roots of cubic equations. You can also sometimes factor them by kind of like visually guessing. That's the way that I do it. Or doing like synthetic division once you figure out one of your roots. I'm not sure. There's probably like a box format way that you all learned that. And very worst case scenario, you can Google it. So for this one, I factored it ahead of time by looking at it and thinking about what the roots would be. And if you want to talk through that process, please come to office hours. But it ends up being m minus 1 times m plus 2 times m plus 2. And when I set that equal to 0, I'm getting the root m equal 1 here, and m equal minus 2 here, so it's repeated. Once. Well, I guess it's repeated twice. Yeah, let's say twice. You have one repeat of it, so you have 2 copies. So in this case, oops, no. In this case, the solution is y equal to c1 e to x from m1 plus c2 e to minus 2x from that first case I saw of m equals minus 2. But then I can't reuse it again unless I multiply by x. E to minus 2x. That's going to be my general solution to this differential equation. And I like this example because it shows that you like combine that repeat case with everything else you find, just in case you were wondering. Now, in the next set of videos, we're going to go ahead and talk about a different case of odd roots you might encounter.